A vector is a quantity that has both magnitude, numerical size, and direction. For example, 50 meters traveled, distance, is not a vector, whereas 50 meters west of the origin, position, is a vector. Vectors can point in any direction and will often be directed diagonally in two dimensions, the x and the y. Because of this, it's often useful to break it into components, as described in detail in another lesson. Once in component form, you might be told that a diagonal force is equivalent to 150 newtons left and 50 newtons up, for example. You may also see this written with unit vectors in the form 150i plus 50j. But you could be asked to use those components to figure out the direction of a vector. The direction of a vector is just the way the vector arrow points. For example, you might have a car moving with a velocity of 40 meters per second west, in which case west is the direction. Or you might shoot a cannon at 80 meters per second at an angle of 30 degrees, and then 30 degrees is your direction. But how do we figure out the direction when we're only given the two components? Let's go through how to do that by doing an example. To figure out the direction from the components, it helps to draw a diagram, and the diagram we draw is called a vector triangle. This triangle shows the overall diagonal force and the two components that make it up. For example, let's imagine you're moving to a different house, but you don't have anyone to help you, so you end up dragging the kitchen table across the floor. You apply a single force that is equivalent to pulling the table 40 newtons east and 20 newtons up. So we could draw this on a diagram, an arrow for 40 newtons east and one for 20 newtons up. Then add the third side of the triangle, which is the overall force, the magnitude of the vector, and we have our vector triangle. But how does this help us figure out the direction? Well, the overall force is the diagonal, the hypotenuse of the triangle, and that also shows us what direction it's pointing. If we figure out this angle, theta, we will know where that diagonal is pointing, and therefore the direction our overall force is pointing. Since we know the adjacent side of the triangle, the side between the angle we're interested in and the right angle, and we know the opposite side of the triangle, the side opposite the angle, we can use the TOA part of SOHCAHTOA to figure out the angle. That tells us that the tangent of the angle is equal to the opposite side divided by the adjacent side. So sine theta is equal to 20 divided by 40. We want to figure out the angle, so take the inverse sine of both sides and we get 30 degrees. So the direction of our force is 30 degrees above the horizontal. And that's it, we have our direction. A vector is a quantity that has both magnitude, numerical size, and direction. An example of a vector will be 50 miles per hour north, but vectors can often be given in component form. You might be told that a diagonal force is equivalent to 150 newtons left and 50 newtons up, for example. This makes it hard to know exactly what direction the vector is pointing. You have to calculate it. The direction of a vector is just the way the vector arrow points. For example, you might have a car moving with a velocity of 40 meters per second west, in which case west is your direction. To calculate the direction of a vector given in component form, you need to draw a vector triangle where the adjacent and opposite sides of the right-angled triangle are the two components. Then you can use the tangent equation from SOHCAHTOA to figure out the angle inside the triangle. The direction your hypotenuse is pointing is the direction your overall vector, whether a force or velocity or something else, is pointing.